Welcome to the Volume and Mass Final Exam Review. Here are the definitions for volume and mass. I find that many students, despite my encouraging them all the time to get this down, wait until the end of the year and the final exam before they bother to learn the difference between volume and mass. Or maybe that's not it. Maybe you guys do think you have it down, but you keep forgetting it as the year goes on unless you use it a lot. I guess it's one of those things that's easy to forget. Volume is how much space something takes up. Mass is how much something resists being moved, or sometimes we think of mass as being the amount of matter in something. I give you both definitions of mass because it kind of depends on the situation which of those definitions you want to use. For example, in physics, we often use the definition that mass was a resistance to being moved. If you have mass, you resist being moved. The more mass you have, the harder it is to move you. But then in chemistry, we tended to look at it as the amount of matter in something. And the reason there's two definitions is because the second one, the definition of mass that says that mass is the amount of matter, that definition kind of conflicts with the definition of matter, which the definition of matter is anything that has both volume and mass. So then you're going in a circle. You can't have two definitions that use each other to define each other. So that's why we came up with a second definition for mass. In any case, this picture is showing you that you have a red ball and a blue ball on a balance, which is technically different from a scale, although we use the words scale and balance kind of interchangeably. Technically, scales measure weight. And weight is related to mass, but it's not the same thing. Weight has to do with gravity. If there's no gravity, there's no weight. Of course, there's always gravity, because gravity is a force that penetrates every corner of the universe. There might be very little of it in some parts of space, but there is gravity pretty much everywhere. However, your mass doesn't change, because your mass is due to the amount of matter that makes you up, and that determines how hard you are to move around. Gravity is just one force that can move you around. You can use other forces to move things around. So if these two balls were floating in outer space in a place that had very, very little gravity, you would still find that it would take effort and work to move them backwards and forwards in space. So those are the differences between volume and mass. So now what? Well, one of the key things we learned this year was that mass doesn't change. The law of conservation of mass, which is similar to the law of conservation of energy, says that mass can't be created or destroyed. If you have a closed system, which is what the universe is, it's a system nothing can get in or out of as far as we know. In a closed system, mass is always conserved. Conserved means saved in this case. So here are some examples. In the upper left-hand corner, if we take some sulfur and some iron and we heat them together, we'll get a nice glow in our test tube, similar to what happened with our copper and sulfur lab. And then, when we're done, we'll have a slug that doesn't look anything like the sulfur or the iron and is no longer magnetic, similar to what happened with the copper and sulfur lab. When you do this, as long as you maintain a closed system, as long as you put a balloon over the top and don't let anything in or out, you should find that the mass of your reactants adds up to the mass of your products. That's because the same atoms that were there before are going to be there after. Look at the picture just underneath. It's showing you the same concept, only this time it's showing you with pictures of atoms. In the left, you have two molecules of hydrogen gas. The hydrogen is a diatomic gas, which means that it's bonded to itself. So there's two molecules of hydrogen gas and one molecule of oxygen gas. And those things combine to form water. When that happens, notice you have 4 hydrogens before and 4 hydrogens after, 2 oxygens before and 2 oxygens after. This is the law of conservation of mass. Now, if you do this in a container that's not closed, you might appear to lose mass. Those oxygen atoms or some of those water molecules might escape on you, and then when you go to take a measure of the mass, you might find that you have less mass. But those water molecules are out there somewhere. A good example of this is the picture on the bottom right. When we burn things, we have this idea in our head that you lose mass when you burn something, because you started out with these big logs and you end with ash. So it looks like there's less stuff. And it's true that it's taking up less space, so the volume seems to have gone down. Although technically, if you're thinking about all the molecules involved here, some of them became a gas, right? And those molecules are now actually taking up more room than the logs did, even though they're very far apart and they don't have any more mass. Even when you burn something, the law of conservation of mass applies. You can't create or destroy an atom. So any atoms you start with, you end with. They may not be in the same spot they were in before. They might be in a different state than they were before, but they'll still be there. There are a lot of questions on the exam that test your understanding of the law of conservation of mass. Just get it through your head right now. Mass does not change in a closed system. If mass appears to change, it's going to be because your system is not closed. Don't forget that. Volume, on the other hand, changes all the time. The volume, the amount of space something takes up, has to do with how the molecules or atoms are spaced relative to each other. And we know lots of things can affect that. Temperature is a great example. When water freezes, it freezes in this open circular pattern that you see on the left-hand side here. And so it takes up a lot more room as ice than it does as water. And then it takes up even more room as steam as the particles move further and further apart. However, the number of oxygen and hydrogen atoms isn't changing, so the mass is staying the same. Likewise, we saw that we can make a sphere, down on the bottom here, expand by heating it so that it will no longer fit through a ring. The particles that make up that sphere are the same particles. They haven't gained mass, they're the same number and type, but they're further apart, so they take up more room. Even in a chemical reaction, it may appear to you that a significant change in mass has happened, just like with the fire burning, it seems like you've lost mass. Here, it might seem like, well, now we're creating a gas, we must have more stuff. Well, actually, we don't. The stuff is just spaced further apart, and the volume changed. Last but not least, you need to be able to find volume two different ways on the test. One way is regular solids. If it's a box of some kind, a cube or a rectangle, you can use this formula that you see down at the bottom. Take the length, multiply it by the width, multiply it by the height. It doesn't matter which side you call the length, which one you call the width, which one you call the height, because you're just multiplying them together anyway, so it doesn't matter. And you can do that for any regular solid. When you do, if you measured in centimeters like we did here, your units in the end will be centimeters cubed. Or if you use a graduated cylinder on the right-hand side to find the volume of a liquid or an irregular solid, I should say liquids and irregular solids, then you might use milliliters. Milliliters are already cubed, so we don't add the little 3. And an irregular solid can be placed in water, and this is called displacement, volume by displacement. And when you put the object in water, the water has to move out of the way, and the amount that the water level rises, the difference between where the water was in this cylinder before adding and this cylinder after adding the rocks, is the volume of your object. So you should be able to find volume both of those ways. And that's really what you have to know about mass and volume for the test. See you guys in class.